Bismillahirrahmanirrahim. Welcome back to my channel. In this video I'm going to teach you how to actually use your software defined radios to check your attenuators, if your attenuators are working properly. I'm talking about passive attenuators, something like this. You probably have seen it in my other videos, like for example this one is a 10 dB attenuator and cascaded with 6 dB attenuator, and then I also have another 10 dB attenuator right here, and followed by another 20 dB attenuator which is being cascaded together. You can just simply unscrew this attenuator. On one side you have SMA female, and on the other side you have SMA male. So like let's say for example, if you don't have your VNAs, if you don't have VNAs available, you can use a simple software defined radio. In our case I'm going to use PlutoSDR, which is right here, which is connected to my laptop. And you can also use your RTl-SDR dongle, which is also connected right here onto my SDR, onto my laptop. But I'm going to show you using PlutoSDR. So this is a very basic flow graph. In this flow graph I have a signal source that is generating a cosine that is being transmitted through PlutoSDR transmitter right here, and is being received by the receiving end of the same PlutoSDR connected to my laptop. Now it's just going to basically transmit this signal at that particular frequency, which is at 2.4 gigahertz, which is a local oscillator frequency. It's going to transmit at about 150 kilohertz. And at the bottom I also have a receiver flow graph. So what this flow graph is doing, that signal is being transmitted from here and being received here, and the signal frequency is at about 150 kilohertz. All right, and it's going to receive this signal, and we're going to look at it. We're going to look at the signal first, and then to check the working of our attenuators, I'm going to connect my attenuator at the receiving end of my PlutoSDR, and we're going to transmit the signal again, and let's see how much attenuation is being done using our attenuators. So this is just a basic simple way of checking to see if my attenuators are working or not in the absence of VNA and other devices. Alright, so I'm just going to simply run this flow graph. Once I run this flow graph, okay, this is what I'm going to see. So let me zoom out. Alright, so this is what is being transmitted. So this is your transmitted signal. This is what is being received by my PlutoSDR, and this is what a spectrum look like. Based on the highest peak which is there, I'm going to judge this signal is at about 150 kilohertz right now, at 150 kilohertz if you were to look at this number. Alright, so based on that highest peak I'm judging this actually is my signal. Alright, to verify, I'm going to try to reduce Rx gain. So indeed this is my received signal, and this is my signal at 150 kilohertz with negative 25.71 dBm. That's my signal strength. I'm going to keep reducing my Rx gain till I get 0. Alright, so let me just so as you can see, I can signal when my Rx gain, which is a built-in gain of my PlutoSDR, of its low noise amplifier, I have reduced this down to 0. Right, I'm not controlling it with the software anymore. Now the other parameter which I can do to improve the signal, I also have a TX attenuation, the power amplifier, which is just before the antenna, which is present in this board. I'm going to make my attenuation to be 0, transmitting attenuation to be 0, just to get, so my receive gain is 0, my transmission gain is 0, I am transmitting a signal at 150 kilohertz. This is what I'm seeing, This is what is being received in time domain, and this is what I'm seeing right now in frequency domain. All right, so let's just quickly look at it. How much is that signal is? So that signal at about 151 kilohertz. I just need to move my cursor. Negative 40 dB. All right. So this is going to be our base. Based on this, we're going to judge what if the attenuation indeed is taking place. If I use attenuators, passive attenuators like these. All right. So Rx gain is 0. TX attenuation is 0, 0. My frequency is set to 150 kilohertz. Right now I'm receiving a signal at 150 kilohertz that has a signal strength of about negative 40 dB. So now what I'm going to do, I'm going to stop this. I'm going to stop this flow graph. And I'm going to stop this flow graph. What I'm going to do, I'm going to unscrew it, unscrew my antenna. Unscrew my antenna, and I'm gonna put a 20 dB attenuator. I hope you can clearly see this is indeed a 20 dB attenuator. So I'm just gonna simply screw it here onto this port. So just to remember, at TX0 and RX gain 0, at 150 kilohertz, I was getting about negative 40 dB. This is my baseline. Based on that, I'm going to judge how much attenuation is taking place. So I'm just going to simply screw this back. Alright, so let's just run this now. Simply, I'm going to run this flow graph. And the flow graph is running. Now, this was my receive signal. So what I'm going to do, I'm going to bring my attenuation down to 0. TX attenuation down to 0, RX gain down to 0. Both of these values are 0. Let's look at our spectrum. The spectrum that I'm seeing right now, so it was at 150, you were getting about negative 40 dB. Now it went down to at least to negative 54. Which means this attenuator, indeed it was rated for 20 dB, it is providing me with an attenuation of negative 14 or approximately negative 15 dB. So just mounting an attenuator at one end, I can see that I have an attenuation of about negative 15 dB, even though this attenuator is 20 dB. So this is a basic way, easiest way to check if your attenuation is good, if your attenuators are working without having to go through your VNA and doing it. You can also perform exactly the same test using your RTl-SDR dongle. In RTl-SDR dongle, the way I would do it, I'm just going to simply unplug this. The way I'm going to do it is this. I'm going to just simply unscrew this. And I'm going to put my attenuators right here, and based on that I'm going to try to receive a signal first, because this is a receive only dongle. RTl-SDR dongle are only receive only. I'll try to first receive the signal and find out what is the baseline, like, you know, what is it without the attenuator. Then I'm going to mount my attenuator again, and I'm going to see how much my signal went down with the help of one of these guys which are there, so we can see the functionality. So a cheapest way of checking to see if your attenuators are properly working. If you have any questions, leave it in the comment section, and don't forget to like and subscribe to my channel.